We are on the second to last assignment, which is section 5.7, which is about matrix operations. So, again, with a matrix, if you have a matrix and you want to list what its size is, the size of the matrix is the number of rows it has. So, in this case, we got 3 rows. So, we could say it's 3 by, and we have 2 columns here. So it's size 3 by 2. So when we want to determine a matrice's size, we use the number of rows it has by the number of columns. What we're going to define first is addition of matrices, and then subtraction, and then scalar multiplication. All 3 of those are super easy. Then we'll look at matrix multiplication, which is a little weird, but it's not too bad. So let's say we have a matrix like 7, 1, 3, 6, -2, 4. So it's a 2 by 3. And we want to add another 2 by 3 matrix to it, like this. When you want to add 2 matrices together, you can only add them together if they're the same size. This is a 2 by 3. This is also a 2 by 3, so we should be fine to add them. And when you add them, it goes coordinate-wise, which means we take the upper left entry here. It's first row, first column. We add the first row, first column entry here. So 7 plus 2 is 9. Then we get 3 plus -1 is 2. So basically what I'm doing is 7 plus 2 is 9. Then I'm going through and doing 3 plus -1 is 2. And I'll continue on just doing that position by position. So we'll get like 1 plus 1. Well, 1 plus 1 is 2. And we'll just go through the whole matrix like that. So I'm going to get rid of those little colors, but that's basically how it works. So let's see, we get 1 plus 1 is 2. We get 6 plus -4. 6 plus -4 is 2. -2 plus 3 is 1. And 4 plus 6 is 10. And that's our answer. So it's just like regular addition, but you go through and you just add the same positions in the matrices together. If the matrices are not the same position, so let's say like we got a 1, 3, 6, 5, and we have a different size matrix like plus a 3, 1, 6, this we can't do. So can't do this because the matrices are not the same size, so we can't add them together. So you could say does not exist. So for addition, the matrices have to be the same size in order to add them. And as long as the matrices are the same size, then when you go through and you add them, it just works out like you want it to. So 2 plus -1 is 1. 1 plus 3 is 4. 4 plus 0 is 4. And 6 plus 7 is 13. So that's addition. Just go through and it works exactly how you'd like it to. You just add the same position in the same matrix, and you get your answer as long as the matrices are the same size. If the matrices are not the same size, then you can't add them together. So addition is not too bad. Let's see about subtraction. Again, to subtract 2 matrices, they have to be the same size. So let's say we have a 3 by 1 matrix and we subtract a different 3 by 1 matrix from it. This works basically the same way as addition, except the second term is going to be subtracted. So we get 4 minus 6. 4 minus 6 is -2. We get 1 minus a -3. Minus a negative is positive, so this is really 1 minus -3 is 1 plus 3, which is 4. And then 7 minus 1 is 6. So nothing real fancy to it or anything. It's should work just the way you want it to. So let's take a look at subtraction like this. 2 minus 2 is 0. 4 minus 4 is also 0. 1 minus 3, 1 take away 3 is negative 2. 6 take away a negative 2, so 6 minus negative 2. Minus a negative against positive, so 6 plus 2 is 8. And that's that. If you have two matrices that aren't the same size and you want to subtract them like this, we can't do that. So does not, oops, I spell not, does not exist. So the matrices have to be the same size to add them and the same size to subtract them. And it's pretty easy. It's just works exactly how you'd want it to. Next thing we're going to get is called scalar multiplication. This is basically what happens if I have a number and I want to multiply a matrix by that number. Well, what you do is, so it's scalar multiplication when you multiply a matrix by a number. What you do is you just multiply all the entries by the number. So 3 times 1 is 3, 3 times 3 is 9, 3 times 7 is 21, 3 times 6 is 18, and that's basically it. So like if you had a negative number and we wanted to do this, we would get negative 2 times 1 is negative 2, negative 2 times negative 3 is 6, negative 2 times 6 is negative 12. So that scalar multiplication is basically if you have a matrix and you're multiplying it by a number, you just multiply all the entries of the matrix by that number, and that's it. So you guys will see some homework problems that deal with like just regular addition, regular subtraction, scalar multiplication, and then they kind of put those three topics together, and you'll get some like this where maybe A is this matrix, let's say 1, 3, 6, 2. B is the matrix 1, 4, 1, negative 1. And C is the matrix, say 2, 1, negative 2, 0. And they want us to find what is 2 times matrix A plus 3 times matrix B minus the matrix C. So we want to find this. So what we do here is we'll write down the matrix 2 times A. We'll write down the matrix 3 times B and the matrix C itself, and then we'll just add the 2A and the 3B elements together and subtract the C element, and that'll get us our answer. So 2 times the matrix A. 2 times 1 is 2. 2 times 3 is 6. 2 times 6 is 12. 2 times 2 is 4. We're going to add that to 3 times the matrix B. 3 times 1 is 3. 3 times this one is 3. 3 times 4 is 12. 3 times negative 1 is negative 3. And then we subtract from that the matrix C, which is 2, 1, negative 2, and 0. So once you get that taken care of, all our matrices are the same size, which is what we need, because if we're going to add and subtract, the matrices need to be the same size. Then we're going to take the top position here, add the next top position to it, subtract this top position. That'll get us our answer there. Then we'll go through and say, okay, let's look at the 6. The 12, those colors look the same, basically. Let's grab a different color. So you'll do like the 6 down here, the 12 down here, the negative 2 down here. That'll get us our answer there. And then we'll get like the 12, the 3, minus the 1 will give us there. And then the 4, the 3, the 0. You add the 4 and the 3, subtract the 0. That gives us the answer there. So that's basically what we're going to do with this process. Just go through and do it real quick. 2 plus 3 is 5. 5 take away 2. 5 take away 2 is 3. 6 plus 12 is 18. 18 minus a negative 2. That's minus a negative 2, so it's plus 2. 18 plus 2 is 20. 12 plus 3 is 15. Take away 1, that's 14. 4 plus negative 3 is 1. Take away 0. 1 minus 0 is 1. We'll take a look at one more of these. And then let's say we get matrix A is 4, 3, 2. And then matrix B is 1, 0, -1. And we want to find what is A minus 2 times the matrix B. So I'm going to write the matrix A down. I'm going to leave a minus here, and then I'm going to write down 2 times the matrix B. 4 take away 2. 4 take away 2 is 2. 3 take away nothing is still 3. 2 take away a -2, so 2 minus -2 is 2 plus 2 is 4. So you guys will see something like that in your homework. It's not too bad. You just go through and kind of multiply your matrix by what it says, and then you just go through and add or subtract position-wise to get your answer, and just make sure that all the matrices are the same size. So the last topic in this section is matrix multiplication, and this is a little weird because the matrices don't have to be the same size to multiply a matrix by another matrix. There's still a pattern that needs to be held. So let's say we got matrix A is, let's say, 4, 1, 2, -1, 3, 0. And matrix B, let's say, is 1, -1, 4, 2, 3, -3. And we want to find A times B. So the first thing you want to do, matrix multiplication is not commutative, which means whatever matrix is multiplying on the left has to stay on the left, and whatever matrix is multiplying on the right has to stay on the right. So kind of the weird thing about these matrices, how you check if you can do the multiplication, is you write the number of rows A has. So A is a 2 by 3. And then next to it, you put the matrix B, which is the right matrix, which is also a 2 by 3. The middle numbers in this case, they don't match, so we can't multiply. So if you write whatever matrix is on the left, you write its size down first. Whatever matrix is on the right, you write its size down. And then you check the middle two numbers. And the middle two numbers have to be the same for matrix multiplication to go through. So this example does not exist. So what we're going to do is we're going to make up one that we can do. We'll check its size and make sure that we can multiply it. Then these outer numbers tell us the size of what we'll get back if the matrix does exist, and then we'll say how the process works. So let's say A, again, is a matrix like, let's say 1, 3, 6, -1, 0, 2. But this time, let's say B is a slightly different matrix, like 2, -1, 0, 1, 0, 3. And we want to find A times B. Well, A and B are not the same size still, so if this was addition, we would say can't do it. And actually, if this was addition, the first one would be okay. So this right here would be okay if we were adding them because they're the same size. But with multiplication, even though these are the same size, we can't multiply them together. In this case, these are not the same size, but A times B is a 2 by 3. Or sorry, A is a 2 by 3. B is a 3 by 2. The middle numbers match, so this time we can multiply. And the outer numbers tell me the product will be a 2 by 2. So this time we're okay to go through and multiply. Again, it's a little weird because the matrices aren't the same size. And we saw in the previous case when they were the same size, like with addition and subtraction, it's okay to add them. But with matrix multiplication, it's not okay to add. You have to check when you write the left-hand matrix size down and the right-hand matrix size down, do the middle numbers match? And if the middle numbers match, that means the number of columns of matrix A has to be the same as the number of rows of matrix B. So what we'll do is we'll write matrix A down. We'll write matrix B down next to it. And the way I've learned, there's a couple different ways you can do this. You can kind of view these rows tilting and lining up with the columns, or you can view kind of the columns tilting and lining up with the rows. Whenever I learned this, I was taught the columns tilt method, and that seems to work pretty good because there's space to write stuff out. So what we're going to kind of visualize is this 2, -1, and 0. We're going to view it. We're going to kind of write it down over here where 2, the first number becomes the first number over here. Middle number goes above middle number. Last number goes above last number. So I took the first column here and I tilted it over. And now I'm going to hit the top entries and the bottom entries with it. We'll multiply them entry-wise and then add up the multiplication, or add up the products. So we'll get a 2 times a 1 plus a -1 times a 3 plus a 0 times a 6. And then when we hit the bottom entries, we'll get 2 times -1. We'll get -1 times 0, so plus -1 times 0 plus 0 times 2. So I've basically gone through, So I've gone through and I multiplied this times this, plus that times that, plus that times that. Then we do the same to the bottom. This times this, plus that times that, plus 0 times the 2. So now we're done using the first column tilted. We're going to tilt the second column, 1, 0, 3. And we'll repeat the process. We'll hit the top numbers and then the bottom numbers. So we get 1 times 1 plus 0 times 3 plus 3 times 6. And then down here we'll get 1 times -1 plus 0 times 0 plus 3 times 2. So now we add all this stuff up, and that is our answer matrix. And we'll do a couple more of these because these are kind of weird. So let's see. It's 2 times 1 is 2 plus -3 plus 0. Down here we get 2 times -1 is -2 plus 0 plus 0. Out here I get 1 plus 0 plus 3 times 6 is 18. And then down here I get -1 plus 0 plus 6. Total those up. Normally when I do these, I skip the first step and jump from here down to this second step. Total this stuff up. Let's see here. 2 plus -3 plus 0 is -1. -2 plus nothings is -2. 1 plus 18 is 19. -1 plus, that's a 6. -1 plus 6 is a 5. Okay, so that's that one. So let's do another example or two of these and just kind of see some weird cases and stuff and just get more used to it. Let's do a kind of straightforward 2 by 2 one. Let's say matrix A equals 2, 1, 4, 0, and matrix B equals -1, 3, 5, +1. And we want to find A times B, and then we also want to find B times A. So A is a 2 by 2. B is a 2 by 2. A times B, the middle numbers match, and we're going to get a 2 by 2 back. So this one's okay to do. A times B, we can multiply, and we'll get a 2 by 2 back from the multiplication. So let's write down matrix A first. Let's write down matrix B second. So we're going to tilt the first column, which is a -1 and a 3. And we're going to hit the top entries with -1 and 3. Then we'll hit the bottom entries with -1 and 3. And then we're done using -1 and 3, and we'll tilt the 5, 1, and hit the top entries, the bottom entries, then we'll add stuff up. So -1 times 2 is a -2, plus 3 times 1 is 3. So that's hitting the top entries with the tilted column. -1 times 4 is -4, plus 3 times 0 is 0. So we are done using the -1 and the 3. Next, we'll tilt the 5 and the 1. So 5 and 1. 5 times 2 is 10. 1 times 1 is 1, so it's a 10 plus a 1. 5 times 4 is 20. Plus, let's see here, 1 times 0 is 0. So we add this up, and we get -2 plus 3 is 1. -4 plus 0 is -4. 10 plus 1 is 11. 20 plus nothing is 20. So that is our matrix A times B. Well, then we wanted to find B times A. So for B times A, B is a 2 by 2 as well. A is a 2 by 2. So the middle numbers still match. The outer numbers still go through. So B times A is also, we also can multiply it, and it will be a 2 by 2 back. So it's okay to multiply, and it's 2 by 2 because since this number, when we write it the other way, 2 by 2 is B's size, 2 by 2 is still A's size, so it's the same thing. So we put the B matrix first, -1, 5, 3, and 1. We put A's matrix 2, 4, 1, and 0. So we saw A times B ended up being this matrix. B times A is going to usually end up being a different matrix. Sometimes it ends up being the same, but most of the time you end up with different things, and that's fine. That's supposed to happen. 2 times 4, or sorry, not 2 times 4. 2 and 4 are what we're tilting. So 2 goes above this, 4 goes above that. We're going to multiply them together to the top entries. 2 times -1 is a -2, plus 4 times 5 is a 20. 2 times 3 is a 6, plus 4 times 1 is a 4. Done using the top first column. So we're going to tilt the 1 and the 0. So 1's there, 0's there. So we tilt the 1 and the 0. That's a 0. It's just a little messy. What we get is 1 times -1 is -1 plus 0. Then we get 1 times 3 is 3 plus 0 times 1 is 0. Total these up. -2 plus 20 is 18. 6 plus 4 is 10. -1 plus 0 is -1. 3 plus 0 is 3. And we can see this matrix is very different than this one. We got a 1 there. There's an 18. We had 11. We got a -1. -4 and 10. 20 and 3. These are not the same matrix at all. So that's fine. That's going to be something that happens when you do these. Let's take a look at a couple more cases, like 2 more multiplication cases, and then we'll kind of stop there. So let's say matrix A is one of these, like let's say 3, 1, 4, 0, 2, -1, 4, 1, 3. And let's say matrix B is a single column, 3, 1, -2. So A is a 3 by 3. B is a 3 by 1. If we want to find A times B, A is 3 by 3, B is 3 by 1. The middle numbers match. We're going to get a 3 by 1, a 3 by 1 back. So our answer is going to be a 3 by 1. So we'll write matrix A down. We'll write matrix B down. So what I'll do is we'll tilt the column here. We'll put the 3 above this, the 1 above that, the -2 above that. We'll hit the top entries, then the middle entries, then the bottom entries. And since there's not a second column to tilt, once we get done with that, we just total stuff up. So 3 times 3 is 9, plus 1 times 1 is a 1, plus negative 2 times 4 is negative 8. Middle entries, 3 times nothing is 0, 1 times 2 is plus 2, negative 2 times negative 1 is plus 2, then 3 times 4 is 12, 1 times 1 is 1, negative 2 times 3 is negative 6. Add all this stuff up. We were supposed to get a 3 by 1 back, and we're going to. 9 plus 1 is 10. 10 take away 8 is 2. 0 plus 2 is 2. Plus 2 is 4. And 12 plus 1 is 13. Take away 6 leaves you 7. We end up with a 3 by 1 back, and our 3 by 1 is this matrix here. So let's look at, let me think. Let's say matrix A is 4, negative 2, negative 1, positive 3, and matrix B is 1, 1, 2, 1. And we want to find A times B. A is a 1 row, 4 columns, so it's a 1 by 4. And B is a 4 column by a single row, so B is a 4 by 1. Whoops, when I wrote find A x B like that, I should probably write it. Probably should just write it as like find AB. So find A times B. B is a 4 by 1, so A is a 1 by 4, B is a 4 by 1. Middle numbers match. So we're going to get a 1 by 1 matrix back, which is a little weird. And then we'll reverse and we'll find B times A. So we get 4, negative 2, negative 1, 3. B matrix is 1, 1, 2, 1. So when we tilt B, we get a 1, a 1, a 2, and a 1. This will equal 1 times 4 is 4, plus 1 times negative 2 is negative 2, plus 2 times negative 1 is plus a negative 2, plus 1 times 3 is 3. 4 minus 2 is 2, minus another 2 is 0, plus 3 is 3. So we get the matrix, a 1 by 1 matrix consisting of the single element 3 when we do it that way. We get a 1 by 1, and basically you tilt the column, multiply and add it up. Once you add these 4 terms together, they collapse down to a single term. Let's see, what about find B times A? What if we do it the other way? B is a 4 by 1, A is a 1 by 4. So if we flip it around, the middle numbers still match, and we're going to get a 4 by 4 back. So B is 1, 1, 2, 1. And A is the matrix 4, negative 2, negative 1, and 3. So we take the first column, which is just 4, we tilt it, and we put the 4 above the first column here. And now we're going to go down, and we're going to hit all the entries here by 4. So 4 times 1 is 4, 4 times 4 is 4, 4 times 1 is 4, 4 times 2 is 8, 4 times 1 is 4. So that's our first column. We took the first column entry here, wrote it up there, and then just multiplied on down. So next we grab the next number, which is a negative 2. We're going to multiply on down. So negative 2 times 1 is negative 2. Negative 2 times 1 is negative 2. Negative 2 times 2 is negative 4. And negative 2 times 1 is negative 2. And real quick, let me just make this part extend a little bit further. So we tilted the first number, we got the first column from it. We tilted the second number, we got the second column. We got to do this for the third number and the fourth number. So third number is negative 1. So when we multiply all these by negative 1, we get negative 1, negative 1, negative 2, negative 1. So that's basically that. And then we get a 3 up here. So we get 3 times 1 is 3, 3 times 1 is 3, 3 times 2 is 6, and 3 times 1 is 3. So we were supposed to get a 4 by 4 back, and we do. So when you have these like 1 by 4s or 4 by 1s or 1 by 3s and 3 by 1s, they're not too bad to deal with. They just can be a little weird to look at. I think kind of the weird thing here is instead of, usually we're tilting an entire column with multiple numbers. When you have kind of the single row matrix is the second one on the right, you're tilting a single number at a time. Okay, last one we'll do. I know we said that a couple times ago, but let's say A is a 3 by 3. These are about as big as you'll see in this course. So let's say that we got a 3 by 3, and B is also a 3 by 3, and we want to do just A times B, and we'll stop after that. So we want to find A times B. A is a 3 by 3, B is also a 3 by 3. The middle numbers match, and the outer numbers tell me I'm going to get a 3 by 3 back. So I'm going to write A down. Going to write B down. And then we'll go through and multiply this out. And this is about as bad as these will get in this section. So let's grab the first column, 2, negative 2, 1. We'll tilt it, and we'll write out our answers. 2 times 1 is 2. Negative 2 times 0 is 0. 1 times 3 is 3. So now we're going to hit the middles. 2 times 2 is 4. Negative 2 times 1 is negative 2. 1 times 2 is positive 2. Hit the bottom entries. 2 times negative 1 is negative 2. Negative 2 times negative 1 is positive 2. 1 times 2 is 2. So we're done using the first column, so we'll scribble it out, and we'll tilt the second column, which is 0, 0, 2. So we're going to hit the top entries, then the middle entries, then the bottom entries. 0 times 1, 0. 0 times 0, 0. So 0 plus 0 plus 2 times 3 is 6. 0 times 2 is 0. 0 times 1 is 0. 2 times 2 is 4. And then 0 times negative 1 is 0. 0 times the other negative 1 is 0. And then 2 times 2 is 4 again. And now we're on to the last ones. Scribble out these numbers. And we'll do a 1, 4, negative 3. So 1, 4, and a negative 3. So 1 times 1 is 1. 4 times nothing is nothing. Negative 3 times positive 3 is negative 9. Then we get 1 times 2 is 2. 4 times 1 is 4. Negative 3 times 2 is a negative 6. 1 times negative 1 is a negative 1. 4 times a negative 1 is a negative 4. And then negative 3 times 2 is a negative 6. Now we just add these up, and we'll get the 3 by 3 back that we're supposed to. Let's see, 2 plus 0 plus 3 is 5. 4 take away 2 is 2, plus 2 is back to 4. Negative 2 plus 2 is nothing, plus another 2 is 2. 0 plus 0 is plus 6 is 6. Then we get 0 plus 0 plus 4. 0 plus 0 plus 4. 1 plus nothing, take away 9 is negative 8. 2 plus 4 is 6, take away a 6 is 0. And negative 1 minus 4 is negative 5. Minus another 6 is negative 11. And that is our answer. So that's about as bad as they'll get in this section of homework. And that should be all the different cases you guys need to do it. So yeah, we'll stop there.